I'm looking at a dataset where some features have very different ranges. For example, one feature might range from 0 to 1, while another ranges from 1,000 to 10,000. This is a common problem in machine learning because these differences in scale can heavily bias the model. To address this, I'll use standard scalar.fit_transform from scikit-learn. This is a function that helps me standardize my data. It will center the data around a mean of 0 and scale it so that the standard deviation becomes 1 for each feature. The standard scalar is a tool within the scikit-learn library which is extremely useful for preprocessing data. It's like giving all your features a fair chance. After applying the transformation, I'm testing my understanding by answering multiple choice questions about the properties of this new data. After standardizing the data using standard scalar the mean of each feature will be 0. This is a key characteristic of the standard scalar transformation. Similarly, after applying standard scalar the standard deviation of each feature will be 1. This ensures that each feature contributes equally to the model, without being biased by its scale. Nope, this is false. The range of the data will change after standardization, because the goal is to have a standard deviation of 1 which inevitably changes the original range. This is also false. The standard scalar doesn't magically make the data normally distributed. It simply changes the mean and standard deviation, not the overall distribution shape. I'm talking about using scikit-learn's standard scalar to change the data. Think of it like this. You have a bunch of ingredients for a cake, but some are measured in teaspoons and others in cups. Standard scalar makes sure everything's measured in the same units, making the recipe easier to follow, and the model easier to train. Imagine you have a dataset where one feature is height in centimeters, small numbers, and another is income in dollars, potentially large numbers. These features have very different ranges of values, which can cause problems for machine learning models. Standard scalar is the tool that tackles this imbalance. This is the specific tool I'm using. It's a function within the scikit-learn library, a collection of powerful machine learning tools. Standard scalar's job is to standardize your data, making each feature have a mean of 0 and a standard deviation of 1. After I apply standard scalar to my dataset, this is the result. It's the same data, but now all the features are on a similar scale, making it much more suitable for machine learning algorithms. This is the core of the quiz. We're testing your understanding of how standard scalar changes the data, and checking what properties the changed data will have. Let's see if you can ace this. This is a quiz about the standardscalar function in the scikit-learn library, a popular Python library for machine learning. We'll explore how it changes datasets. This question asks you to consider the effect of using standardscalar on a dataset. I will assess your understanding of how this function transforms data. After applying standardscalar, each feature in the dataset will have an average value of 0. This is a core aspect of standardization. The standardscalar also makes sure the spread of the data, measured by the standard deviation, is 1 for each feature. This ensures consistent scaling. No, the range, the difference between the maximum and minimum values, will almost certainly change after using standardscalar. The goal is to standardize the deviation, not preserve the original range. This is false. The standardscalar only adjusts the mean and standard deviation. It does not change the data's shape or distribution. If the data started non-normal, it remains non-normal. This question asks you to think about what happens to your data after you use the scikit-learn tool standard scalar. Standard scalar is like a data chef that makes sure all your ingredients, data points, are on the same scale. It does this by making the average, mean, of each ingredient 0, and the spread, standard deviation, equal to 1. It's a really common way to prepare data for machine learning models. Think of it as making sure all your ingredients are perfectly balanced for your recipe. Yes, standard scalar centers the data around 0. This means after applying standard scalar, the average of each feature is 0. This is a core part of how standard scalar works. That's right. The standard deviation measures the spread of your data. Standard scaler scales the data so the spread, standard deviation, of each feature is exactly 1. This ensures all the features contribute equally, preventing features with larger scales from dominating others. Nope. By making the standard deviation 1, standard scaler changes how spread out your data is. The range, the difference between the maximum and minimum values, will almost certainly change as a consequence. Not necessarily. Standard scaler only changes the mean and standard deviation of your data. It doesn't magically make your data look like a bell curve, normal distribution. If your data wasn't normally distributed to begin with, it won't be after applying standard scaler. I'm using STANDARDSCALER, a tool from the SCIKITLEARN library, to pre-process data. This means I'll adjust the data's scale to make it easier for a machine learning model to work with. After using STANDARDSCALER, each feature in my dataset will have a standard deviation of 1. That's a key part of how STANDARDSCALER works. It standardizes things. Another thing STANDARDSCALER does is to center the data. So, after I use it, every feature will have a mean of 0. It's like moving the data so the average is precisely at 0. This is false. STANDARDSCALER changes the range of the data. The goal is to get a standard deviation of 1, which inevitably changes the range of values. This is also false. STANDARDSCALER only adjusts the mean and standard deviation. It doesn't change the shape of the data's distribution. If my data wasn't normally distributed before, it won't be afterward. Imagine you have a dataset. Some features, like the number of items purchased, might range from 1 to 100. Others, like the total cost, could range from $10 to $10,000. These are features with different scales. The STANDARDSCALER is going to help us make these scales more uniform. After I apply, I standardize the features. This means each feature will have a mean of 0 and a standard deviation of 1, creating consistency across the features irrespective of their original scales. This is awesome for machine learning algorithms. This row is describing the situation before you apply the STANDARDSCALER. It shows how the features have vastly different ranges or scales. This is a common problem in many datasets, and it is what we are trying to solve using this scaler. This is true. The STANDARDSCALER will center the data around a mean of 0. This is part of its magic. This is also true. The STANDARDSCALER scales the data so each feature has a standard deviation of 1. This is also fundamental to its functionality. This statement is false. Remember, the range changes when you scale and center your data. I'm adjusting the spread and shifting the values to achieve a standard deviation of 1 and mean of 0. This is false. The STANDARDSCALER doesn't change the shape of your data's distribution. It only standardizes the mean and standard deviation. If your data was skewed before, it will likely remain skewed after the transformation. This refers to the process of using the STANDARDSCALER from the scikit-learn library. This is a very common and widely used technique to pre-process data for machine learning. It's all about making data more consistent and easier to work with. This is the method I call to actually perform the scaling. The fit part determines the mean and standard deviation of each feature, and the transform part applies this to center and scale the data.